Now we will do some problems. The first question is, the transfer function of a phase lead compensator is given by g of s is equal to 1 plus 3ts divided by 1 plus ts, where t is greater than 0. What is the maximum shift provided by such a compensator? So we know the expression for this already. Sin phi m, where phi m is the maximum phase shift. This is equal to 1 minus a divided by 1 plus a. Now it is given that it is a phase lead compensator. So for phase lead, a will be less than 1. So here 1 minus a will come out to be a positive value, right? So phi m will be a positive phase shift. If it was a lag compensator, then 1 minus a will be greater than 1. So you will get a negative value. So phi m will come out to be a negative value, which is what we want in a lag compensator. Okay. So now here you need to find out what is the value of a. So you compare the given transfer function with the standard transfer function. So here, since t is already taken in the given transfer function, we will take a different variable. Okay. So the standard transfer function we will take as 1 plus tau into s divided by 1 plus a tau into s. Okay. So from here, if tau is equal to 3t, then this implies a tau is equal to t. So this will give you a is equal to 1 by 3. If you substitute tau is equal to 3t. Okay. So now sin phi m is equal to 1 minus 1 by 3 divided by 1 plus 1 by 3. So you're going to get 2 by 4, which is 1 by 2. So what will be phi m? Sin inverse of half is 30 degrees. This is the maximum phase shift. The next question, the transfer function of a lead compensator is given by s plus 1 divided by s plus 2. The phase will be maximum at dash radian per second. So that means you have to find out omega m, the frequency at which maximum phase shift occurs. Okay. So what is the expression for this? 1 by at into 1 by t whole root. Okay, which is the geometric mean of both the corner frequencies. So now the given transfer function is s plus 1 by s plus 2. If you write it in the time constant form, you're going to get 1 plus s divided by 2 into 1 plus s by 2. Now what is the standard transfer function? This is 1 plus ts by 1 plus a ts. So from here you can see that t is equal to 1 and a is equal to 1 by 2. Okay. So we can get omega m is equal to root over 1 by 2 into 1. So this is going to give you root 2 radian per second. The next question, for the given network, the frequency in radian per second where maximum lag occurs is. So how to do this? The main formula remains the same. The frequency at which maximum phase occurs is omega m, which is root over 1 by at into 1 by t. But here the only difference is that we don't have the transfer function. We have to find out the transfer function from the given network. Okay. So transfer function is equal to V naught by V in, which is equal to 1 plus 1 by SC, C is 1 farad, divided by 1 plus 1 by S plus 9 ohms. Okay. This is by the voltage division rule. So this you are going to get as 1 plus S divided by 1 plus 10 into S. So from here you get that T is equal to 1 and A is equal to 10. Okay. So omega m is equal to root over 1 by 10 into 1, which is 1 by root 10 radian per second.